All right, so one of the other things we've got going on with the Huntsville Center for Technology is this lunar terrain simulator that we started on last school year, towards the end of the year. The kids in Mike Evans' design group designed the moonscape, and then they, along with one of the actually electronics tech class, started building part of the floor system. Come back in this school year, and they finished off most of the floor system. That's what you see there on that image. That was status as of yesterday, I guess. And that is all on casters out there in the lab there at HCT. And I think it surprised all of us at how easy that was to move around. And it takes very little effort to roll that entire system around, as big as it is. So the next thing, we're going to put some plywood down over those pieces of lumber there, and then we'll start putting on some high-density styrofoam. It's going to be our lunar surface. We were talking yesterday about how to paint that once we get the styrofoam in place to make it look more, lunar moon surface-like. And then we've identified our regolith material that we're going to use. It's some crushed limestone that we have available, pretty readily available and pretty inexpensively from Vulcan Materials here in town. We don't think we'll ever completely cover the entire surface with the regolith at any one time, because it would be a dust hazard and cover that whole thing and weigh about 11,000 pounds of regolith that we'd have on there. So I think what we're going to do is kind of keep maybe a sandbox of that stuff somewhere and put it on areas as we need, and as we want to do some testing and driving and showing off. But I think we've got a pretty good plan in place to complete that, and we're looking at having that done this first semester by the end of the year here as well.
Ray, I think you can't really tell from here, but so you have a lower slope here, but on the backside of that is our more steep slope for testing different maneuvers, right?
Yeah, so you got a flat part there in the front that's 12 feet by about 9.5 feet, and it kind of goes up a pretty slow incline. I forget that was. I think it was maybe 15 degrees or so, 15 or 20 degree incline, and then it gets a flat place on the top, and on the backside there it's a pretty steep incline, like a deep crater is what that's supposed to represent. So it's a pretty steep incline and a short 45-degree incline on the backside. That would be the steepest part of the moonscape, and so we can do some pretty tight maneuvering and climbing testing on this thing, as well as I think it's going to look pretty cool for photo ops and such.
Great.
And we've got a 3D model from actually came from Caleb, who I believe is the team leader on Sotillo's lander team now, and he worked on the last year with a couple other students working on the moonscape design. We've got his CAD image that we're going to take and give to Michael and some of the Marcom guys, and kind of make that as a little marketing version of what our moonscape's going to look like. Kind of use that as a go-by a bit as we start getting into the finer points of the thing built.